So we got sleeping in today. All right, so today we're going to be looking at regression analysis. In regression analysis, or simply like regression, graphing regression lines and curves, to kind of get your brain in the right place. Do you remember, like way back in Algebra 1, way before me, where Miss Tyree or somebody, they plotted a bunch of points and they asked you to draw a best fit line? Do you remember doing that? Where you tried to draw a line and it was kind of like hit or miss, right? You just kind of eyeballed it and went, I don't know, something like this. And the idea of that was, if I could get a best fit line, then I could use that line. If that's the most accurate approximation of the points, I could maybe use that line to determine what might happen in other places. So for instance, if I only had points like this, you know, and so I kind of eyeballed it and drew a best fit line in there. And these were values like at 1 and 2 and 3, 4, 5, 6. I know that's not very consistent, but whatever. If I had that I could use this to say, well, what happens at 7? And I could come up here and use that line as a way to approximate what might happen at 7. Or maybe like what happens at 5.5. I could use this line to maybe approximate that, right? And that's the idea of a best fit line. Well, a best fit line is a regression line, okay? And you don't just eyeball it. There's actually a way to do it. And back when I was in school, we actually had to do it. Like we actually had a formula when we took stats in college where we calculated how to find that actual regression by doing this system and finding, basically you'd say, if there was a line there, there's a distance, and you try to average these distances from the line, and you'd have a way to do that. Well, that becomes increasingly harder when I go from best fit lines to maybe best fit curves, right? Because even though I could certainly draw a best fit line here, right? I could do that. Probably some kind of curve might look better. Might be a parabola, might be a cubic, who knows? So what we're going to do is kind of throw out all those formulas and let our calculator get busy and do the work for us. And there's a whole part of your calculator on regression that enables you to calculate linear, quadratic, natural log, exponential, all kinds of regressions. And I just want to walk you through how to do that. And in the past, I think one time I was absent this day and I didn't want to waste a day. So I created this lesson to walk you through it. So they're pretty good notes. They're pretty wordy from the standpoint of, I'm not going to read every little bit of this. I just want to walk through it. But if you ever get lost or whatever, of course, you can always go back and watch the video. But you can come in here and look at this and kind of figure out or remind yourself what we're doing. So please, as we're going through this, please commit to the second you start feeling like you're behind because some of your calculators are not going to behave correctly. Just raise your hand or yell out or say something because if you get like 5 steps behind, then like, I don't know what I'm doing. Then we have to go all the way back. So if you don't get it immediately, just say something and we'll fix it because you can expect that your calculator will have some issues comparative to mine. Okay, especially if you have a borrowed calculator or your siblings' calculator because they've probably already done this, and I don't want you building your stuff on top of what they've already done. Are you with me? Okay, so I'm going to turn this on real quickly, but we're going to be following along with this lesson. So a lot of what I've already talked about, I've basically explained, but we're going to be using as soon as this thing comes on. We're going to be using, if you look at that page 90, whatever, page 93, there's a list of 6 points. And we're going to just pretend that those 6 points represent times and speeds, okay? We're going to let time be seconds, maybe, and speeds be meters per second. So basically, somebody has clocked every 1 second something speeding by, and you can see the speed at time 0, at time 1, at time 2, at time 3, at time 4, at time 5. And we're going to take this information and we're going to enter in our calculator using the programming we have. And by the way, who takes stats in here? Okay, you're going to probably know more sometimes about what we do. Now, maybe not with regression, but when we get to the stats part, you may know more and maybe other ways to use your calculator that I don't. Great. A lot of your work is just an answer. So if you're like, man, we could do this so much easier this way, feel free to tell me. If it makes sense to what we're doing, yeah, I'll work it into my notes. But I might do things a little bit differently because I'm not an expert in stats, and you're learning from somebody who knows stats better than me. All right. So here's the idea. We want to plot these things and see which curve fits it best, because it might be linear, it might be exponential, it might be quadratic, might be cubic. Who knows? But we don't have any ideas. So let's see what our calculator tells us about it. So the way you're going to do this, and you're going to go to your calculator, and you are going to obviously turn it on. And when you turn it on, we're going to need to get away from all this function stuff. So I'm going to hit the home screen, and I'm going to go down to the bottom. If you go down to the very bottom right there and over to the middle, it said lists and spreadsheet. So I'm going to hit enter on that. And when I hit enter on that, you should see 1.1. Does anybody not see 1.1? Do you see more than 1.1, like 1.1, 1.2, 1.3? Okay, here's what I want you to do. Do you feel like you need any of this? Do you even know why you have those other things? Okay, so do this. Go up to the top, hit X, and it's going to say, do you want to save it? And just say no. All right? And then do it again. Click enter on spreadsheet again. Now do you see 1.1? Okay, so everybody's got a 1.1 and nothing else? Because if you have other junk in there, and by the way, you can save these things. If you have anything else in there, like on a test, if you have other junk in there, then you're going to start mixing your questions together. And you don't really want to do that, right? You don't want the graph of one mixing in with the points of another, etc. Okay, so we normally don't live over here on this. We normally just live on our little scratch pad. Like if you get off this page right here, we are normally over here on the calculate graph side of things. But there's also the document side of things, where you can open new documents and make new documents, whatever. That's kind of what we're doing. This, you're just doing work. Here you can save stuff. So like if you ever wanted to save a bunch of junk, you can do that over here on this area. And you can store it as different files, name different files, whatever it is you want to do. I just normally don't like doing that because I'm reusing stuff. I mean, I'm typically not reusing stuff from day to day. But anyway, so I normally live here, but we're kind of over here now when we click on this stuff. So here we go. I am back. Oh, there we go. I didn't want that. Delete. A little trouble. Okay. So once I'm in here, we're going to be entering our times and our speeds in this column. So what I want to do is label those. So in this box A and B, I'm going to label time right there in A and time right there in B. Now, you can actually do a lot with this, kind of like an Excel spreadsheet if you're familiar with those. And you can put programs and formulas in here as well. But we're not doing any of that. We're going to be doing an analysis with a built-in program. So I'm going to go ahead and label that time and speed. So I'm just going to go up to A and type in time. You could type in whatever you want. And then I'm going to tab or go over to the right. And then I'm going to hit speed. Not speed. Speed. And then I'm going to come down to my first box, my box one, and I'm going to start entering the times. And then I'm going to enter all the speeds. And if you hit tab, it just jumps to the right, which is kind of annoying because then you got to get back here. So I just do down arrow, and I think it's a little easier that way. So 0, down arrow, 1, down, 2, down, 3, down, 4, down, 5. And then I'm going to come back up, and I'm going to enter those times. Now, guys, on your test or on your work, if you enter one time incorrectly, everything's going to look different when it comes to your answers. So you always need to get in the habit of double checking and making sure what you enter has the right decimals. You haven't missed a space. Be really careful about that. So 2.5, 3.1, 4.3, 5.9, So I'm going to double check my values and make sure I'm in good shape. Now, once everything is in here, all right, now I want to actually do a regression. And there's all kinds of different regressions. So to do a regression, what I want to do is I want to go one space over to the right. I don't think I have to be on that. I could maybe be somewhere else, but I'm going to go to this one spot here, and I'm going to calculate a regression. And the way to calculate, like, is the way to do almost everything on your calculator. You're going to go to your menu. And when I click on the menu, you're going to see stats as an option. So I'm going to click 4 on stats. So again, I hit menu, and I hit 4 for stats. And it says, well, what do you want to do? Well, I want to do a stat calculation. So I'm going to hit 1, and you can see all the different regressions that are offered to you. Now, you'll notice there's 2 linears. It doesn't really matter which one you use. I kind of like the MX plus B because I'm a little comfortable with MX plus B as an educator. So I'm going to first do linear just because I have no idea what this thing looks like. I'm just checking them. So I'm going to click 3, and it's going to jump me to this. Now, this is basically prompting you to fill in what we're going to be doing here. So my X list was the column labeled what? That was your time, right? So what I do is I just click, in the middle of my button to kind of drop down the menu, and I'm going to choose time. And then I'm going to go down and tab to Y, and Y was your what? Speed column. So I'm going to click on that and choose speed. And then this next blank says, all right, we're going to calculate this regression equation, but we're going to save it as a function. And this is why you want to start fresh, because if you don't start fresh with a new document, there might be other F1, F2s, F3s in there, and I don't want them on my graph. So if I start fresh with a new one, I can put I'm going to store it as F1, and you'll see that in a second. It'll just store it there, and then if I want to go look at the graph, I can hit enter on F1, and it'll graph this actual regression. And then I have no idea what frequency list. It doesn't affect us. But one other thing, if you go down, all the way down to the bottom, this says, where do you want to put your results? And it always seems to leave an open spot, like an open free column in between your A and your B. And if you do that, then your results sometimes are off the screen. So I don't like to leave an open column. So I always, if I have stuff in A and B, I like to put that in C, my results. So my results will actually show up in 2 columns, C and D, as opposed to having stuff in A and B, skipping C, and then jumping and having D and E. So I change it. You don't have to, but you'll see what I'm talking about in a second. I'm going to change that to C because nothing is yet in C. And if I hit enter right there, you can see your stuff show up. Now, if I had not changed that, I would not have had stuff in C and D. I would have had it in D and E. Do you see the issue with that? Yes, no? Okay. So what this is saying is, all right, I did a linear regression. This was my regression equation, mx plus b, and this is my slope value. This is my y-intercept value, and then it starts giving me information. Now, this information I want to talk about. If you've had stats, you understand what an R value is. An R value is basically a correlation coefficient. It basically tells you how accurate you are. A perfectly accurate regression curve, like literally one that hits every single point, would have an R value of 1. Okay? So, and then a perfectly worthless regression would have an R value of 0. Now, there are also R values of negative. And negative means a negative one could actually be very useful. A negative one actually says basically it's almost like opposite day. That's the best way I can describe it, is if, you know how if it's opposite day when you're like, did y'all do opposite day? Okay. So like if it's opposite day and I'm like, you're so ugly, right? And you're like, thank you, right? Because it's opposite day, right? Anyway, that would be kind of like a negative regression. We're really not going to look at those really too much. And now I know when you're dealing with linear curves, there are positive and negative regressions, but we're going to be focused more on positive R values. So this is actually an R squared value. And again, you in stats would know more about this, but the R squared value is just directly, it's related to the R value just mathematically. So if I square rooted that value, you would see the R. But this one actually lists R. If you go down one, there's your R value. And 0.98 is pretty close to 1. which means this is a fairly accurate regression. But if I had another curve with an R squared or R value bigger than these two, then great, that would even be a more accurate regression. Now, in real life, sometimes you got to overrule a regression. Like for instance, what if, and I normally do this in this class, I don't know if I'm going to, maybe in a day or two, I normally get everybody in here to and I go and measure their heights and I measure their shoe sizes and we do an in-class regression and their ages. And I look at that and see if the things that we're measuring actually make a little sense. And sometimes we find that, you know what, a quadratic curve actually fits the information better than a linear curve. But do you think, for instance, that shoe size and age are quadratic? Because if they are, what would that mean as you got younger? Your shoe size gets bigger? Are you really born with like a size 50 shoe and then it shrinks on down to something smaller and then grows bigger again? So sometimes you got to look at it and go, okay, even though maybe a quadratic curve fits your information a little better and gives you a little better R value, that might have been just some coincidences. Are you kind of following me? Like for instance, if I plot the temperatures of the year and I look at them and over like the high temperature each month, and let's just say I start with January and it goes something like this. I might be tempted to think, man, that looks very quadratic. And I might graph that quadratic and think, oh, quadratic regression gave me the highest R value. But let's be honest, is the next February, March, April just going to spiral down to like sub-zero temperatures? No, what's really happening on these temperatures? Nice sine curve, maybe a cosine curve or whatever. So the point is, sometimes even though an R value might fit better in a real life situation, don't forget to, don't accidentally check your common sense at the door. Now, my tests are not asking a whole lot of common sense stuff. Not that would get you in trouble. So, but just make sure you're thinking, because sometimes you need to obviously step in there and overrule. All right. Anyway, so right here, I got a pretty decent R value. Anything else I need to talk about? I don't know about this, what this resid means. Again, if you're in stats, you may know all this stuff. But what I want to do now is show you a couple things. I want to show you how you can graph this. And then I also want to show you how you can plot points. Although hear me well here, and this is not in your notes. I'm going to put something there. Don't plot the points on your test. Remember, our goal, I just want to show you that you can. Right? Our goal when we when we find these regression curves is to use the regression curve to predict stuff we don't know, right? So who cares about the points? But I do want to show you that you can actually plot those. So if I did want to plot them, flip over the page. All right. Oh, before I even plot them, what I want to do now is graph this thing. Remember when we initially started the regression, it said, where do you want to store the function? And you said F1. Well, it's stored there, but you don't have a graph connected to this document yet. So what we want to do is add a page. Now you can add a page a couple of different ways, but the easiest way is right there, add page. So I'm going to hit Control Doc. And it says, well, what kind of page do you want to add to this? And you can add anything, but I'm going to add a graph page. So I'm going to hit 2 or scroll down to graphs. And when I do that, you'll see, look, 1.2. So you have a second document added to this. That one's cool.
It went off yesterday.
Did it? Huh.
Did you take attendance?
No, the earlier one goes for attendance. That's like, I don't know. I live off alarms. Enjoy your 50s and beyond. Can't even remember your own name if you don't write it down. It's not that bad. Whatever. All right, so what I want to do is graph this. Now, you'll notice when you pull up this graph screen, what does it send you to? F2. Well, guess what? There's something in F1, and it is, if you go up, there is your graph. Now, it's not graphed yet because you haven't hit enter. I don't know why it does that, but you now have to hit enter right there, and it will graph your linear curve. So that is the linear regression that goes through the points that you had. Now, you don't see the points because you haven't plotted them. You've only plotted the line, okay? Now, you already know that on this function, you can plot functions, and you can also do parametric equations, right? Remember when we changed it to parametric by going to menu right here, and then going to graph entry, and then choosing parametric? Remember that? And it gave you the X and the Y. Well, look what else they have as an option. Scatter plot. They also had polar, right? So if you go to scatter plot, which is 6, it says, hey, what do you want to plot? What are your X's and Y's? Now, what were my X's? Times. So go to vars. You don't have a drop-down menu here, but if you go to vars, a little var button, and you click on var, it gives you all those things. So you can go down or go up to time. If you go up, you jump to the bottom. I want time as my X, and then I can go down and go vars speed as my Y, and when you hit enter, it plots the points. Now, you don't normally want to do this. In fact, let me just tell you, don't do this on your test. And the reason why is when you go to actually start solving and using this, your calculator, it's kind of like having an extra graph on there, and it's grabbing values from different places, and it confuses it. Well, it doesn't confuse it, but it'll confuse you. So I'm just showing that you can do this, but you don't need to do this. Are y'all with me on that? Okay, but I just want to show you and also show you, you can't see all your points because you're on a standard window. So this is the best time, if ever, to hit zoom fit. Okay, so if you want to go menu, window is 4, and zoom fit, which is A, it will redo your window and give you a nice box around your points. So the zoom fit is really, I have people all the time that go, why don't you hit zoom fit on this? And I'm like, well, the curve it's a polynomial. It goes forever left and forever right. How does it know what to fit into? But on points, it does a great job of going, oh, here are your points. So even if your points are like 10,000 to the right and 50,000 up, it'll go and put a box around all your points and give you a decent looking graph for that. So you can see this thing actually fits pretty well, and it makes sense that I would have a pretty high R value. But if you look closer at it, what else do you see? Kind of looks like maybe a curve would fit a little better. You seeing that? Since there's like a point here, and then a point kind of on it, and a point below it, a point kind of on it, a point above it. Kind of looks like a curve might fit better. So let's try another regression. So here's how you navigate once you bring the screen, once you bring a graph in. I can take my cursor and go back to 1.1, which is fine. But let me show you another way you can do it. If you look to the left of this touchpad, do you see that? This right here has a page arrow. So if you want, you can just hit Control left and it'll jump 1.1. And on the right side, you see a little page arrow. You can get Control right and jump back. And if you ever want to see, like if you ever start getting to where you have 5 and 6 screens, which you won't in this class, but if you ever did, you can see all of your windows at once by going Control up. See that? It's like, oh, you can see all the boxes by going Control up. And then you can just move from one to the other real quickly without scrolling through all of them. So just to understand how this is navigated, you can manipulate that way. And also, if you don't know this yet, you know you can always undo an action, like go back. You can undo an action by right there by hitting Control Escape. So like if you're like, okay, I see the points, but I really don't want them now, I could undo that Control back arrow. Oh no, it's actually going back through all of my movements. Okay, Control back. Maybe not. Maybe it doesn't do that. Okay, most of the time though, when you do something, you can hit Control undo and it will undo it. I'm going to leave those in here for now. Now what I want to do now is do another regression. So I'm going to go to the left page, go back to 1.1. Oh well, maybe I'm not. Go back to 1.1. I'm going to go move over to an open space. So I'm going to move to an open space, and I'm going to do another regression. This time I'm going to try a quadratic. So menu, stat calculations, and then quadratic is down there at number 6. So I'm going to see if a parabola fits in here. Now, what is my X list again? So click on that and choose time. My Y list is speed. I want my function to show up as F2, which makes sense. Now, if you're sick of F1 and you don't want to see F1 anymore, then just change that to F1. And you can, does it have a drop down on that? Well, no, actually it doesn't. But look, it's easy to change it to F1 literally by backspace, put a 1 in there. So if you want to do it over your other graph because you're sick of seeing it, knock yourself out. You can't. But I'm going to want both of them on there just to kind of compare them. And then once again, I'm going to scroll down. All right, now it's saying they're going to put it in F. But if you remember, my entries were in A and B. And then my results of the first regression were in C and D. So I don't want to skip E and go to FG. I'm going to put EF. So I'm going to change that F to E. But again, if you're looking at that and like, I don't care about a column, then don't worry about it. Just hit enter and you'll be good. But right here, you'll see there's my new regression. So my quadratic regression. Now quadratics have AX squared plus BX plus C, right? So it's saying there's my formula. There's your A value. There's your B value. There's your C value. And when I scroll down, you'll notice something here. There is no R value. But there is an R squared value. So if I wanted the R value, what would I have to do? Square root that. Now, I'm not a huge fan of writing down 0.99760, especially since it's not even exact. What's exact is 0.997598158332226. But you can copy and paste on this just like you can in a Word document. So if you hit Control calculate your R value. So one way to do that is to go back to your scratch pad. But if you want, you can just add a scratch pad. Watch this. Add a page. I just want to add a, is it the calculator page? Okay, so what I could do is, if I am currently, like I was on, hold on. Okay, so I was right there. I'm going to hit Control C to copy that value. Then I'm going to go over to an open page and do the square root of, and then I'm going to hit Control V to paste it in there, and then I can just hit Enter. And now I have my R value. Y'all seen that? And you don't have to do a special page like a 1.2 for that. You could leave this and go and just go to your other real scratch pad and then come back to your document. But I normally kind of like to keep everything together. Maybe I don't normally like to, but I sometimes keep everything together. And it's a reminder of what I've been working on too. And if you want to store that as R, knock yourself out. Y'all know how to store values? If you don't, all you got to do is hit where vars is, right above it says stow, hit Control Store, and just store it as an R and hit Enter. And that'll be your R value. So from here on out, if you ever hit R and hit Enter, you're going to see that R value. And if you're worried about, well, wait a minute, that's going to have R value for all eternity. You're right, it will, until you store another value on top of R, or until you go to your menu and your actions and you clear A to Z. If I hit menu actions, clear A to Z, it'll delete all my variables that I've had stored. But I rarely delete anything. I just keep storing over stuff, and it's fine. All right, so I've already calculated the regression. You can see it right here at one point. You can see it. Blue. I don't know what that is. Oh, that's for calculus. Okay. I'm going back to my, all right, sometimes it gives me issues. I'm going back to my 1.3, and I want to be able to graph what was stored as F2. Remember that? So I want to graph that. Well, remember, if I hit Tab, it's going to be, well, actually, what's it doing right now? Still on the stat plot stuff, right? I don't want that. So I'm going to hit Menu, Graph Entry, put it back on Function, and now you'll see it's on F3. Why is it on F3? Because it's already put stuff in F1 and F2, but I haven't activated F2. So I'm going to go up, and now there's my F2, which hasn't been activated yet. I just hit Enter, and there's my parabola. And you can see that parabola there really hits almost every point right through it, it looks like. So I'm guessing that that R value is probably a little bigger. And sure enough, if I go back, remember, check it out. The R value was 0.9988, Well, the R value of my line was 0.9833. So a 9988 is closer to 1 than a 9833. So I would argue, I'm betting that the quadratic regression does a little bit better. It's a little bit more accurate. But if this didn't make sense, does that mean if I go back in time, I might have been actually increasing? Was I actually slowing down as I neared time zero and then speeding up again? Maybe. I don't know enough about this situation to determine that. But if it did not make sense, I might go, okay, even though it fits a little better, it doesn't really make sense. So maybe I just aborted and jumped to what does kind of make sense and go with it. Just kind of making sense for you guys? Okay, so honestly, I really don't like, if I'm doing the work, and I've mentioned this already, I do not like to see those points in there. So I'm going to go menu, graph entry. I'm going to go back to the scatter plot, and I'm going to go up to S1, and I'm going to delete that junk and hit enter so the points are gone. And I'm also going to, just for the sake of it, just to show you how we're going to operate, I'm going to go back to function now, graph function. And I'm also going to get rid of the line. So F1 right here. I'm going to delete that. Struggling. Okay, I'm going to get rid of that whole line, and I'm going to see if I can answer some questions. Now remember, I only had times 0, 1, 2, 3, 4, 5 in there. So if I were to ask you right now, hey, tell me what would happen at time 6 based on this quadratic regression, what would you do? You could trace it if you want. Now, you got to remember this too. Tracing, it's great, but keep in mind, if I want a y value at 6, and I already have this graph as y2, watch this. Couldn't I go to my scratch page and go, hey, the y value, which would be f2 at 6. Isn't that saying y at 6? Y'all tracking with me on this? This is not in your notes. But isn't that saying the y function at 6? And then I could just hit equal, and it could spit that out. Now I can trace too, but I could know that I can also do this. Tracing sometimes requires me, depending on your calculator, to change my window up to actually get there. But yes, I could have traced. I could have said menu, trace, graph trace 1, and it says, well, where do you want to trace to? And you could scroll to 6 if you wanted to, although you can see it's sometimes it jumps over the whole number. Do you see that? From 3.9 to 4.2. And you remember, if you're on trace, which you know you're on trace, you can just enter a whole number value like 6. You can see I've entered it, and I can hit enter, and it jumps to that 12.12 also.
How'd you get the F2 to work? Mine says error. Oh, because mine's F1.
Y'all see this?
Did you go into like a scratch pad?
No, I'm on the calc. I did on the other one. If I want to go to the scratch pad and use F2 or F1, if that's how you have it labeled, it would depend on how you're setting it up. You can go to that little blank sheet of paper. But if you're doing this, I just hit trace on the graph sheet. Is there any question on that? So like, let's just say I wanted to find the value at 100. Well, again, here, I'm already on, I can hit trace. You can see that little X there. So I can just enter the number 100. And when I hit 100, it's going to change my graph so you can see it. So a lot may change because I'm up there at 1808 now. But you can see that at 100, I'm at 1808. But I could also have done that by going to 1.2 and saying F2 bars F2 of 100. And it'll spit out that 1808 because it's already saved as a Y value. Now, the hard part for you, and it's not really hard, but the hard part is, what do you do when I say, hey, what X value goes with a Y value of 40? And the problem with that is I don't have a way to do a function. I can't say X of 40 equals, and it spits out a Y. I wish I could. It just doesn't let me. And if it does, let me know how, because I don't know how to do it. So this is how I have to get a little creative. I can do it the hard way, which is not great. And that is, I'm going to go back to my original graph. There we go. Okay, menu, window. So far, my go back is not working very well. So what if I said, hey, what's going to happen to the x value when the y value is up there at whatever? We'll say 20. Well, the hard way is to go, well, I could trace, graph trace 1, and I could go until I set the y value hit 20. But the problem with that is, 1, it takes a little bit of scrolling, and 2 is you can see that it really never lands on 20, does it? You see that? And because it doesn't land on 20, that requires you to have to make increasingly more meticulous little steps on your graph. And you remember doing that when we did regression, which was annoying and crappy. Well, because we're not on a projectile motion, but because we're not on projectile motion, we can do better than that. All I have to do is graph the line y equals 20. And if I graph the line y equals 20, what will that allow me to do? Anyone? Find the intercept. So what I'm going to do is just say, I'm just going to graph another equation. So I'm going to hit tab, and I'm going to graph y equals 20. And it's going to go through the line. And then I can just find the intersection, and the intersection will give me the x value. And that's pretty easy. And I wish I could have done that with projectile motion, but it didn't allow me to do it. It's just something about that part of the calculator. So here we go. Menu, analyze the graph, intersection. And I can say, all right, left bound, pick that, right bound, pick that. And then you'll get a nice, clean answer at 8.539 if you're rounding to 3 decimals. At 8.539 seconds, I would be at 20 feet per second or meters per second, or whatever this thing's doing. So you should now have 2 ways to deal with these. 1, you can find x values. You can find y values given an x value by just tracing. And you can find x values giving a y value by graphing the y equation and finding that. Is that making sense? Okay, you've got some classwork homework that we have not even begun, but I want you to look at it. It just gives you some practice regressions. And I think on the second page, it asks you to do a little bit of this. But you're going to run into some issues. Like, let me just give you a heads up. What if you're doing an exponential regression? What do you think your calculator is going to say if these are the points for your exponential regression? Your exponential regression does not have an ability to shift. So on an exponential regression, it's trying to do this, but it's going to go, and it's going to kind of throw up a red flag and say, you can't have 0 and negative values of y. And it's going to say error. Well, you're still wanting to do one, so what's your best bet on doing an exponential regression? Just eliminating that point, maybe thinking of it as an outlier. Okay? So sometimes there are going to be some, again, I'm going to ask you to basically incorporate your common sense. I am guessing you're going to have questions tomorrow. Make sure you bring them in and get them resolved. All right? All right.
Thanks, Mr.
Yeah, man. Anytime. Oh, did I give you an assignment sheet? No. Sorry.
It was like 7:59. I was like, come on, buddy, you're gonna be. So they almost like.